Yo! Let's talk about some quadratic functions, but we're going to talk about how to graph them in vertex form. Now, you might hear me reference absolute value a few times in this video, so if you don't understand the absolute value function, that's going to make this very, very, very simple. Here is the HK formula, or this is the vertex form for the quadratic function. Now, what we can do is we can point to a couple of these values and show what they do. So this k on the outside, this is a vertical shift from the parent function, okay, or a vertical shift of the vertex. Or this is also, we can even write, it is the y value of vertex. So when we're graphing quadratic functions, basically we always want to start from the vertex, and then we start looking at what the a value is from there. Okay, so we have to always start from the vertex though. So the k on the outside, this is your vertical shift. It is the y value of the vertex. The h on the inside, this is your horizontal shift. And it is the x value of the vertex. But it's always the opposite of what's inside. So because it's in the formula, because in our formula it is a subtraction symbol, then whatever sign we see here, so this is like x plus 2 squared, this 2 would represent negative 2 in the vertex. Okay, so it's always the opposite. Now let's write that down too. Always opposite sign. And then the A represents the rate at which the graph is changing. So this is going to tell you how narrow or how wide it is. This is going to tell you if it's upward or downward. And the nice part, it is the slope of just the first point. And I'll show you what I mean by that afterwards. So that's a lot to copy down. Sorry, I have bad handwriting, but luckily I was telling you what it said as we were going through it, so hopefully you were following along. But let's just start looking at it, okay? So first, instead what we've done in the past, like when we did absolute value and whatnot, I had you guys make a table and graph to see what this minus 4 does. Well, we're not going to do that. I just told you what it does. So if we ever have a shift of x plus or minus inside parentheses and the square on the outside, that's the horizontal shift. This doesn't have that. So I see no parentheses. So that means there's no horizontal shift. So this is basically like x plus 0 squared. Okay. So my x value for my vertex is still 0 because it's not moving left and right. The minus 4 gives me the y value of negative 4 of my vertex. So that's where this particular graph is starting. Now, the a value is what's always in front of those parentheses, or what's in front of the x squared. If there's nothing there, it's just 1. So as I mentioned before, what's nice is that for the very first point over one whole value, this is actually your slope. So this a value right now is just 1, because there's nothing there, so it's 1. So that means the slope for the first point is up 1 over 1. So I have the first points of my graph. The problem is I can't just graph that because now it looks like a v and it looks like an absolute value function. Can't do that. So we need to have 2 to 3 points on each side of the vertex. But luckily, if we have the axis of symmetry, we know we can always plot on one side and that'll give us the points on the other side. So here's what I mean by that. So now that I know that my vertex is here, and I figured out the first point because the slope's just 1. So I went up 1 over 1 for both sides. I want to figure out, well, what's the point when x is 2? Because that's the next one over here. So I actually need to plug in 2 real quick. And I need to solve. 2 squared is 4. 4 minus 4 is 0. So when x was 2, I got 0. Now this is how the axis of symmetry works. So let me draw a dotted line here. My axis of symmetry is here at 0. So when I went 2 away from the vertex, I was up here at 0. So that means if I go 2 away from the vertex on the other side, it is also at 0. And then there's my parabola. Whoop. Like so. So the axis of symmetry for this one is still x is 0. The domain is still all real numbers. My range has changed now from what we've learned before. So my range is, let's see here, it looks like it's always going to be at the vertex, and it's always really going to have to deal with the y value of the vertex. We're opening upwards, so my range is y has to be greater than or equal to -4, because everything above -4 is part of it. And finally, it does have a minimum, and the minimum is y equals -4. Okay, so now let's look at another one. We'll go through this one a little bit faster. So now, instead, there's nothing on the outside of the parentheses, right? So that means there's no vertical shift. So we're not moving up and down, so the y value is 0. I could write +0 on the end. But now there's a horizontal shift. Because this is -3 and we take the opposite, the vertex is at +3, 0. So here's my vertex. Again, there's no number in front here. This is where the A would be. There's nothing there. So that means it's just a 1. So my first point is up 1/1 on both sides. Now, if I wanted to, because I have to, not if I want to, but because I have to have another point, I can look either at 1, because that's the next one over on the left, or I can look at 5. So if I were to plug in 5 for x here, it's x minus 3 squared. If I were to plug in 5, that'd be 5 minus 3 squared, which is 2 squared, which is 4. So in 5 we're at 1, 2, 3, 4. That's 2 away from the axis of symmetry, so 2 away from the axis of symmetry will also be 4. And then there's my graph. So this -3 here on the inside shifted it to the right 3, because normally our parent function always started at 0, 0. We didn't change how narrow or wide it was yet, and that's that. And the way it compares is we just shifted it to the right 3. So I took the parent function. So if the parent function, the one that we learned the other day, was this one right here, teal. So these are the same graph, but I just took this and I shifted it over 3 to the right. That's how they compare. Axis of symmetry also changed. So the axis of symmetry is now, I guess I should keep it in red, huh? Sorry. So now it's x equals 3, because this is where my axis of symmetry is at. It's the x value of the vertex. Domain's all real numbers. Range is y is greater than or equal to 0, because that's the y value of the vertex. That's where all of our values have to be above 0. And we're at a minimum of y equals 3. Okay, so you should be able to write the function by looking at the graph, because it's easy to find the vertex. And then what we need to do is we need to figure out what's the a value. Okay, so first find the vertex. So here's we'll do the first one together. So my vertex is here on this first one. That's at +1, -1, 2, 3. So my vertex is at +1, -3. So if I know the vertex, I know it is going to be parentheses. I have my horizontal shift on the inside, I have my vertical shift on the outside. Well, the y value is -3, so that's just going to go on the outside. +1 for the x value, so that's going to be the opposite of that, -1 on the inside. Now the way I determine if there's an a here is we just look at the first point over. And I want to see if I go over 1, where am I at? And this just went up 1/1, so there's no, I'm not changing the value, or this, I'm not making it wider or more narrow. So there's my function, x minus 1 squared minus 3. No a value here because I didn't change the slope. I didn't change the rate in which it's changing at all. Go ahead and try these two on your own. Just try to write it, get the vertex, and then try to write your whole function. So for this one, vertex is at 1, 2. So that means I'm going to be at x, again, -1 squared, but this is +2 on the outside because we shifted it up 2. That's a -1, looks like almost like a 7, sorry. Now it looks like -7. I made it worse. Okay. The a value, if we look again, it just goes up 1/1, so it's still 1. All right, and then finally for this one, let's see, my vertex is at -2, -1, because there's the vertex. So then, because it's at -2, that's going to be x plus 2 on the inside, minus 1 on the outside, up 1 over 1. So therefore, because I went up 1 over 1, my a is still 1. Okay, so now we're going to look at how this changes and how this has an impact on the graph. Okay, so let's look at these two functions. We're going to write I want you to write the equation of the red graph, which is f of x, and then we're going to write the equation of the blue graph, which is g of x. So for the red one, for f, they both have the same vertex. So the part that's going to be the same is what's on the inside and then what's on the outside. The vertex is at +1, -3. So if I'm at +1, -3, it's going to look like x minus 1 and then -3 on the outside. Oops, sorry. So that part's done. Now what I want to figure out is, well, what's the rate of change? What's the a value here? Well, from here to here, it goes up 1 over 1, so it has a slope of 1. So that's the function for f of x. We're done. For g of x, has the same vertex. So all of this stays the same. Like, this doesn't change. But as we can tell, it is more narrow. If I look at the first point from the vertex to the middle to the next point, it goes up 2 over 1. So that means I'm going to put a 2 there. Because the slope is 2 over 1, which is just 2. Now notice how, again, if I want to find the next perfect point, it's not going to continue going up 2 over 1. That's just for the first points. That's just for the one that's 1 over. Okay, so that's the only time it'll work. And sometimes 1 over, it won't be a perfect point. So sometimes it'll be like this. Okay, and that's when we might have to start plugging some values in, because this, I don't know what this is. This might be 1/2, I would hope, but I don't know for sure. Because that's when we're going to have to find a perfect point and confirm. But we'll go over examples of it like that later on. Okay, so you're also going to, you're going to have the graph from vertex form, now with the a value here. So we'll do this one together, and then I want you guys to do this one on your own. So we always start from the vertex. So always start graphing from the vertex. So I got to pick out my x value, which is -1. Y value is +4. So there's my vertex at -1, +4. And with that being said, I can actually answer my axis of symmetry, because we know that's the x value of the vertex. X equals -1. Okay, I'll even draw it on here. Here, let's do it. There's my axis of symmetry. I know my domain is all real numbers. And we'll answer the range and maximum after we graph the rest. So, got my vertex. Always have to start from there. So all of this part's done. Now I got to see what's happening over here. Well, it's a negative value, so that means I'm actually opening up downwards. And there's a -2, so my first point's going to be down 2 over 1. And that's going to be on both sides of the axis of symmetry. I still have to graph another point. So I need to look at which values I want to plug in. My options are -3, because that's the next value over, or my option's 1. Let's just plug in +1. So this is where you're actually going to have to do a little bit of math. So I plug in 1 for x, and I'm trying to figure out what's the y value when my x is 1. 1 plus 1 is 2. So I have to do 2 squared, which is 4. 4 times -2 is -8, plus 4 is -4. So when x is 1, the y is -4. And then I can go 2 over from the other side of the axis of symmetry, and that's it. There's my parabola. Okay, try this one on your own, I think. Yep, that's our last one. So try that one, and we'll go over it. So pause it, try, oh, I'm sorry, hold on. I guess if you tried it, you're still going to have to listen to it when you unpause it. So the range, because we are at 4, I know it's y and 4, because the range is always at y value. And because we're opening downward, y has to be less than or equal to 4, which means we're at a maximum of y equals 4. Because that's the top of the graph. Okay, pause it, try this one, graph it, see how you do. Okay, so my vertex is here at +2, -3. Done with all of this part of the graph. Because it's 0.5, that means I'm going to go up 0.5 over 1. Because remember, that's rise over run. So because it's rise over run, I'm going to go up 0.5 over 1. up 0.5 over 1. So my rise is 0.5, my run is 1. And we always want to have that run be 1 because now I can figure it out when my x value is 4. Okay, so what I'm going to have to do is I'm actually going to have to plug in 4 here and solve. So again, that's 2 squared, which is 4. So this makes 4, right? Now I have to multiply 4 by 1/2, which is 2. 2 minus 3 is -1. So when it's 4, we're at -1, 1, 2, 1, 2, so I'm at 0, -1. There's your parabola. Okay, for the vertex, we were at +2, -3. Our axis of symmetry was at x equals 2. Domain is all real numbers. I don't feel like writing it, so I'm not going to. The range, it is y is greater than or equal to -3, because that's our y value of our vertex, which means we're at a minimum of y equals -3. Okay, things to remember. Always opposite sign. It's a common mistake. Here's your independent practice. And that's it, guys. Thanks for watching. Good to see you out.